Let's return to our previous example of function that parses CSV file format and our CSV data value and the actual parsing code. As we can see that this code have parsed correctly our CSV data and returned dictionary as we expected it to do because we already done this. Let's now try converting this code so that it uses classes instead of dictionaries as output. Here is the person class that we have created in the previous part with some small modifications. So in addition to the existing name, surname and age arguments that have been previously passed to the constructor of person class, we now have ID argument, which is expected to contain string variable that will be then converted to integer identity number for this person. This is ID of the record in the database. And in addition to that, we also enforce integer type on age variable, so that string will be converted to integer age. And now we are going to iterate all the items of the dictionaries that we have created in previous step and create a new person class from each of those dictionaries. Here are the important parts. So first of all, you can see that we have used .items method of data. This is a standard method for dictionaries that creates iterator. And if we are going to look into it, that is how it looks like. And this is actually basically a list that contains tuples or pairs. In each pair, the first element is the ID of the record, and the second element is the record itself. So in a way, this is similar to zipping the key of the record to the record. And when we iterate this structure, we can use two arguments on the left side of the for. So we will get key stored in k variable and value stored in v variable. Once we have extracted key and value, we can actually start creating our dictionaries. One way to do that would be to take the data dictionary and then extract the value that is stored under certain key. And then we are going to use double asterisk operator to unpack the resulting dictionary into arguments of this constructor. So how does this look like? First of all, for example, if we are going to consider key to be 1, then data 1 is just this set of variables. And if we are going to call this function person, which is constructor for the class person, and pass this as arguments, and if we are going to pass this dictionary values into constructor of class person, then we are going to get person created correctly using the name, surname and the age from the dictionaries that have been provided. This is a shortcut for assigning individually the values of the elements of this data1 dictionary into variables by their name as keyword arguments. And now that we have here a person object constructed correctly, we can then look up its converted to integer identity and use that as a key to our resultant people dictionary and store the new object here. And as you can see, we have created a dictionary that is full of objects, and we have integer keys 1 to 3, and each of the key contains an object of type person that has name, surname and age based on the values from the database. And finally, as an example, we can take one of the keys from the dictionary and take the corresponding person from that key. So in this way, we can easily convert existing data that is stored in the dictionary format, which is only partially structured because it doesn't contain proper data types, and it is not conveniently accessible because you have to use strings all the time. Instead, we can convert it into an object of person class that will handle data type conversion and representation of our person and representation of our person object. What we have created here in programming is usually called model of data. So we have a class that describes the structure of the data that we are getting from the database and is capable of converting the incoming data stream from the database, in this case in the form of dictionary, into the correct representation of the object itself. Usually models have methods that allow them to be converted both from the representation in a specific database and to such representation. So in our case, we only have one half of that. we only have conversion from CSV format. Now this is convenient, but we still need to have this messy conversion beforehand, and that takes extra steps and makes extra code. How can we integrate this conversion directly into this class so that we can have encapsulated parcel that contains everything that is necessary to parse CSV format? To do that, we are going to have two changes. First, we are going to add a new class method. In a way, class method is similar to class properties, but instead of being some global variable that is stored, class method is actually used to create instances of a class. So it is a smart wrapper around constructors. In this case, CLC variable that is passed first into this class is not going to contain a representation of the object itself, what we have in the case of self variable. Instead, it will contain reference to the class in which this function is defined, so that we can use this CLC variable to instantiate the class without referring to its name. What happens in this function? So the first argument is obvious, we have described it right now. And the second argument is a line from a CSV file. And this line is expected to be already split into the individual columns. And then headers is necessary for us to process line elements into correct dictionary elements. Then we basically copy paste our existing CSV parsing code. We do the check of the amount of elements, and then we create a new dictionary, and then we use zip to iterate line elements together with headers. And once we have every pair of value and header, then we just assign value into the corresponding element of the dictionary using the header as a key. And finally, we call our CLS to create a new instance of the object. We will need to modify the second part as well. Here we first take our CSV data and split it into new lines to get individual records and header. Then we process headers, splitting them using commas. And then we go through lines from first to the last using the slice operation for list. And we convert every line split by commas into corresponding person entity using this person dot from CSV syntax. As you can see, from CSV belongs to this person class. So since we don't have any object of type person, we instead reference the class name directly. And as a result of this operation, we get new object of type person, just as if it was a constructor. And finally, we verify that person has been created successfully, because in some cases we might return none here. For example, if our sizes do not match. And if person is not none, then we assign it to the dictionary. Let's see how that works. So as you can see, the dictionary has been processed correctly as well. And now we no longer have any external code that is necessary to work with this. So we already have data splitting here with very simple and minimal 3 lines of code. And everything that is related to actual parsing and conversion is now handled by this class method and this constructor. One important thing about this representation is that this thing at class method is called decorator. We will discuss decorator in the next part of this lecture, but for now you just need to know that this is a way to apply transformations to the functions so that they change their property. In case of classes, the very commonly used transformations are class method, static method, and property. And we will discuss them later. Okay, now we have a class that can read from CSV file and CSV file format. But what do we do if we need to write it back? Let's implement a simple conversion of the class back into the CSV format. To do that, we will add a new method, and this method will be named to_CSV, and we will use it to represent the class as CSV line. So we are not going to handle headers in this line, only the record itself. This syntax is as follows. First, we have a string, and every string has a property called join, and join takes a list as its argument, and then it takes every element of this list, expecting that every element is actually a string, and it creates a concatenated string that is spaced by this string in between. For example, if we're just going to copy this and illustrate this with some constants, let's join two strings A and B with comma. And we execute this, and you can see that we have A, which comes from here, and B that comes from here, and then comma that comes from the element that we used to join. We can change this and have exclamation mark, for example, and you can see that the string changes. And we can have more than one element, obviously, here, and they all will be joined by the same type of string that was specified here. This is effectively the opposite of split operation. So if we are going to have this and then apply split and split using the same exclamation mark, we will get our list back. And for our class, this means that now if we use people key dot to CSV, we are going to get correctly formatted CSV string. And this way we can encapsulate both reading and writing from the CSV format into the same class. And this is a very convenient tool, because now if we are going to pass this class to somebody else, they don't have to think how to implement this again. They can just use this class, and if they need to expand the amount of data elements, then they need to do minor modifications by adding representation here and the new conversion here in constructor. But if they are going to just use it, then they don't have to even think about that. And this turns our data that was separate from our functions together into this encapsulated entity that we call class person. Let's finish our example with proper writing of the list of people into a CSV file. Here two things happen. First, we take our headers structure and create a new list that contains our headers row already formatted. Then we iterate over all people using key and value as key and v, and we can use directly v to access the value of the dictionary, and we use toCSV function to create the formatted CSV string, and we append it to the output list. We still keep these records as a list so that we can add new lines later. And this v to CSV is exactly the same as people k to CSV, because key is basically references the same key. Once we have this list formatted, we can use join and join this list into a single string using /n character, creating properly formatted CSV output. And finally, we use this statement with open file name, and we open it for writing as out file, and then we finally do outFile.write CSV output. We will discuss this statement in a moment, but right now we can check that this properly formats our CSV file here. And if we open files and we go to results CSV, we can see that it's properly written as well. Now this statement here with as is called context statement. Context is created by providing special functions to your class. And these functions effectively define what is about to happen before the context is executed and after the context is executed. These functions are guaranteed to be called regardless of any exceptions that might happen inside your class. So it is in a way similar to wrapping your statement with try except and handling closure of the file, for example, properly at the end of your except block. Not every class provides these context operations, but for files they do. So when we open this file, we create an instance, and this instance will be represented in our context block using this outFile variable, and this outFile variable will only be available within this context. And once we end, the file will be automatically closed. Here is an example of how you can write your own context classes. If we execute this, we can see that first entering my context event occurred, and then we had this function executed properly using the values from MC that we have passed here as an argument, and that has been stored into self.arg of this class. And after this context block has been executed, the exiting function has been called correctly here, also citing this argument, and presenting the list of errors that might have occurred during this execution. As you can see, to create the context, you just need two things, really. you need to define the enter function that will be called on enter into your context, and exit that will be called after your context has been executed. The enter function is very straightforward, it has no arguments, and the exit function has one list of arguments that is normally containing 3 arguments actually, and they will be set to none, all of them, if your function has been executed correctly. Otherwise, these error args will contain the record of error that occurred. For example, if we were to divide by 0 in this context, we will first of all see that we have division by 0 error unhandled, but at the same time, we have exit error args and exit in my context correctly executed before we have dropped into the error handling. And now we have 3 arguments. We first have class of the error here as a first argument, then the actual error object here as a second argument, and then we have traceback object that can be used to print out the location of the actual error happening in the code, which is what we have here. The context objects are actually very convenient property, and if you can contextualize some of your operations, for example, again, if you are working with a database, you can create an object that will have enter and exit functions that will handle creation and destruction of database connection appropriately. And in general, they are very useful for handling any external resources that have some certain state and need cleanup after the execution of certain operations.